So students, we have discussed it before that there are three types of bond. They are the electrovalent bond, the covalent bond and the coordinated bond. Now starting from the electrovalent bond. Okay. Electrovalent bond. Now students, the electrovalent bond is also known as ionic bond. The electrovalent bond is also known as ionic bond. Okay. Now, what is the definition of electrovalent bond? Okay. The transfer of electrons. The transfer of electrons from one atom to the other atom. So what is electrovalent bond? The transfer of electrons from one atom to the other atom is known as electrovalent bond. Now students, remember that when we are telling transfer of electrons, when we are saying transfer of electrons, it means complete transfer of electrons. This means complete transfer of electrons. Okay, when we are using the word transfer of electrons, it means the complete transfer of electrons. Okay, so the transfer of electrons from one atom to the other is known as electrovalent bond. Now, the electrovalent bond is also known as ionic bond, students. Why it is also known as ionic bond? Because the ionic bond is the bond between ions. In between ions. Now why in between ions? And what are the ions? They are the cations and anions. So which ions? They are the cations and anions. Okay. Why it is called as ionic bond? Because it is the transfer of electrons in between ions. And which ions? They are the cations and the anions. Now students, we will study about the cations and anions. So, when an atom accepts or donates electron, it is called as ions. Okay, when an atom accepts or donates electron, it is known as ions. So when it accepts electrons, it is known as anions, and when it donates electrons, these are known as cations. Okay, when it accepts electrons, these are known as anions, and when it donates electron, these are known as cations. Okay. Now we will discuss about the size and the structure of anion and cation, how they are formed. So students, I said that when an atom donates electron, it forms cations, right? It forms cations. So for example, let us take any atom, okay? Any atom which can donate electron. I am taking here potassium. Potassium, whose atomic number is 19. So electronic configuration is 2, 8, 8 and 1. Okay. So this atom having 4 cells, students. So 1, 2, 3, 4. And the first cell contains 2 electrons. Second cell contains 8 electrons. The third cell also contains 8 electrons. And the last cell or the outermost cell or the valence cell contains only 1 electron. Okay. Okay. So 2 in the first cell, 8 in the second cell, 8 in the next cell, and the valence cell contains 1 electron. So it is easy for the potassium atom to donate 1 electron. Okay. It is easy in the case of potassium atom to donate 1 electron. Now why the atoms donate electrons, students? The atoms donate electron to attain nearest to attain nearest noble gas configuration. Okay, the atoms donate electron to attain nearest noble gas configuration. What does it mean? Means they want to fill up their cell with octet rule. Okay, they want to fill up their cell with octet, that is every cell should contain 8 electrons in the outermost cell. If the cell contains 8 electrons, then they are stable. Okay, they want to attain nearest inert gas configuration because they are stable atoms. So these atoms donate electrons or accept electrons to attain stability. Okay, now this potassium atom donates 1 electron. This is potassium atom, right? It donates 1 electron. When it donates 1 electron, students, see, the structures become this. Right, students? The structure become this because it donated 1 electron present in the outermost cell. Right? So when potassium contains 19 electrons over here, here the potassium contains 18 electrons. Now the potassium is donated as K plus. The potassium is donated as K plus because it donated 1 electron. The potassium ion donated 1 electron, and those atoms, okay students, those atoms who donate electron are regarded as electropositive atoms. Okay, those atoms who donate electrons are known as electropositive atoms, okay, or electropositive ions. The element who donate electron, they form electropositive element. So what we read, and these are known as cations. Okay students, the element who donate electron to form positive ion is known as electropositive element, and they are regarded as cations. Okay, the cations are those ions who donate electron to form positive ions. Okay, the cations are those ions who donate electrons to form positive ions. Okay, now students, the cations are positively charged elements. Okay, the cations are positively charged elements. Now the second one, students, atoms accepts electron to form anions. The atoms accept electrons to form anions. Let us take an example. Let us say chlorine. The chlorine atom contains 17 electrons. Right students, the atomic number of chlorine is 17. So 17 means 2, 8 and 7 electrons, right? 2, 8 and 7 electrons. So if we draw the atomic structure, the first cell contains 2 electrons, whereas the second cell contains 8 electrons, right students? And the last cell contains 7 electrons, right? The last cell contains 7 electrons, and inside the nucleus. Inside the atom there is nucleus. Okay, now 17 electrons, students, right? The chlorine atom will accept electrons. The chlorine atom will accept electron. Now why it is going to accept electrons, students? To attain stable, right? To attain nearest inert gas configuration, right? We have said it before. The nearest inert gas configuration, that is 8 electrons, isn't it? To attain nearest inert gas configuration, or we can say to attain stability, right? To attain stability. Okay, now, so the chlorine atom will accept 1 electron to fulfill the outermost orbit. So the chlorine atom accepts electrons and it becomes chlorine ion, isn't it? I said it before, that the atoms donate or accept electrons to form ions. So this chlorine atom accepts electrons, right, and it forms Cl minus ion, which is known as anion. Okay. So students, those atoms who tend to accept electrons, they are regarded as electronegative element. Okay, the atoms who accept electrons are known as electronegative element. Okay students, so students, we have studied about the cations and the anions. The atom who have 1, 2 or 3 electrons in their outermost orbit, or we can say that valency orbit or valency cell, they tend to lose electrons to form cations. That are, they are positively charged ions. Okay, and those atoms having 5, 6 or 7 electrons in their outermost orbit, they tend to accept electron. Okay, their property is to accept electron, and they accept electrons by forming anions. They accept electrons and they form anions, which are negatively charged ions. Okay, now we will discuss about the conditions for the formation of electrovalent bond. Okay students. So students, electrovalent bond is the transfer of electrons, isn't it? Electrovalent bond is the transfer of electrons. Now, which atoms transfer electrons? We will discuss about that. Which elements or which atoms transfer electron? Okay. The atom which have 1, 2 or 3 electrons in their outermost orbit. Okay, the atoms which have 1, 2 or 3 electrons in their outermost orbit, they lose electrons. And the atoms which have 5, 6 or 7 electrons in their outermost orbit, they tend to gain electrons. Okay, the atoms who have 1, 2 or 3 electrons in their outermost orbit, they tend to lose electrons, while the atoms who have 5, 6 or 7 electrons in the outermost orbit, they tend to gain electrons. Okay, the atoms lose electrons and the atoms gain electrons. I said it before students, the atom who lose electrons or gain electrons, they form ions, right? The atoms who lose electrons or gain electrons to attain nearest inert gas configuration, they are known as ions. So the atom who lose electrons are regarded as cations, and the atoms who gain electrons known as anions. Okay, the atom who lose electrons are cations and the atoms who gain electrons are anions, and the cations are positively charged ions, whereas anions are negatively charged. Okay, anions are negatively charged. Okay students. So students, we are going to discuss about the conditions for the formation of electrovalent bond. So students, how the electrovalent bond is formed? The electrovalent bond is formed when an atom when an atom accepts or donates electron to form an ion, right? When an atom accepts or donates electron to form an ion. So the first condition is an atom is having low ionization potential. When the atom is having low ionization potential, so students, why the atoms should have low ionization potential, students? We know that ionization potential is the energy required to remove an electron. So when the energy required when the energy required will be less, then what will happen? Then the atom can easily donate one electron. For example, let us take sodium atom which contains 11 electrons, that is 2, 8 and 1, right? So 2 electrons in the outermost cell. Yes. So 2 electrons in the first cell, 8 electrons in the second cell and 1 electron in the last cell. So the sodium atom will need low ionization potential. Okay, the sodium atom will require low ionization potential, or else it should not require any potential, students, because the sodium atom, as it having 1 electron in the outermost orbit, it will easily donate 1 electron. Okay, it will easily donate 1 electron to form cation. Okay, to form cation, that is Na plus, having 2 and 8 electrons. Okay, we require low ionization potential. Why we require low ionization potential? To form cation. Okay, the atom should possesses low ionization potential to form cation. Why to form cation? Because when we need low ionization potential, it is easy to lose 1 electron for the atom and to form cation. Okay, now the second condition should have high electron affinity. Should have high electron affinity. Now students, we know that electron affinity means electron lover, right? Electron affinity means electron lover is to accept electrons. Right? Electron affinity is to accept electrons. So when the atom accepts electrons, it becomes anion, students, isn't it? When atom accepts electron, it becomes anion. So when any atom accepts 1 electron, it will form anion, right? So it should possess high electron affinity. The chances to accept electron should be high, so it can easily form anion. So here forms cation and here forms anion, right? So cation is also formed and anion is also formed. For example, chlorine atom, students, 17 electrons, right? 2 electrons, 8 electrons and 7 electrons, right? It will easily accept 1 electron, right? It will easily accept 1 electron and will form chlorine minus ion. So Na plus and Cl minus, isn't it, students? So this atom should have low ionization potential and 1 atom should have high electron affinity. Now the third condition is, students, it should have high electronegative difference. Now students, we know that electronegativity difference will be large or higher, then the transfer of electrons will be easier. Okay, students, when the electronegativity difference will be higher or larger, then the transfer of electrons will be easier. For example, students, the sodium atom belongs to the first group and the chlorine atom belongs to the 17th group. It is a very large difference, students. This belongs to the first group and that chlorine atom belongs to the 17th group. So a very large electronegativity difference. This atom can donate electrons, whereas this atom can accept electrons. When they have large electronegativity difference, then it is easier for the atom to transfer electrons. Okay, so what are the three conditions, students? It must have low ionization potential. Secondly, it must have high electron affinity, and third is it must possess high electron affinity. So when the ionization potential will be low, it can donate electrons, students. It can donate electrons to form cation. And when it has high electron affinity, it can easily form anion, right? And when the electronegativity difference will be higher, the transfer of electrons will be easier. Okay, students, so these are the conditions for the formation of electrovalent bond. Okay, so students, now we will discuss why ionic bonds are more stable. Why ionic bonds are more stable? So students, we know that the electrostatic force of attraction between the oppositely charged ions are very higher. Between the opposite charges, the electrostatic force is very higher. That is, when we are coming to the ionic bond, we know that there exist two types of ions, right? They are the positively charged, and next one is the negatively charged, right? When we are coming to the positively charged and negatively charged, we know these are of opposite charges, right? These are of opposite charges, right? And we know that the opposite charges electrostatic force is much higher than others. Okay, is much higher than others. The electrostatic force of attraction between opposite charged atoms is more higher. So the ionic bonds are more stable than compared to other bonds. Okay, because the electrostatic force of attraction is higher in case of opposite charges. Okay, some examples are NaCl, CaO, MgCl2. So students, are ionic bonds. Okay, this bond possesses ionic bond in between them. Okay, in between them there are ionic bonds. So these are more stable than compared to other bonds. Now students, we will discuss the structures of some ionic or electrovalent bond. Okay. Now the first which we know and which we use in our everyday life, the salt is NaCl, students, right? Which we use it in everyday life, right? We use salts in everyday life, isn't it, students, for cooking? So NaCl is made up of ionic bond. Okay. Now the sodium atom having 11 electrons, right? That is 2, 8 and 1. Okay. 2 electrons in the first orbit, 8 electrons in the second orbit and 1 electron in the outermost orbit, right? So the sodium atom contains 11 electrons, that is 2, 8 and 1. Now the sodium atom loses 1 electron to form sodium ion. Okay, the sodium atom loses 1 electron to form sodium ion, and this is known as cation because it carries positive charge, students. Okay, we know that the atom who carry positive charge, that is the ion, that ion is known as cation. The atom who possesses some charges, they are known as ions, and carrying positively charge, they are known as cations. So this sodium atom changes to ion, that is cation, and we know that the cations are smaller in size compared to the parent atom. Okay, the cations are smaller in size than compared to the parent atom. Now this is the Na plus containing 10 electrons in the 10 electrons. Okay. Now coming to the chlorine atom. Okay. So this is Na, right? This is the sodium atom. Now coming to the chlorine atom. The chlorine atom possesses 17 electron, students. That is 2, 8 and 7. 2 electrons in the first cell, 8 electrons in the second cell and 7 electrons in the outermost cell or the valency cell. Now this chlorine atom is eagerly waiting for 1 electron. Okay, this chlorine atom is eagerly waiting for the 1 electron to fulfill its outermost orbit. Okay. Now, the chlorine atom will receive 1 electron, students. Remember, the chlorine atom will receive 1 electron to form chlorine minus ion. And we know that the atom carrying negative charge, that is ion, is known as anion. Right? And how will the structure look like? We know that anion are little bit bigger in size than the parent atom, right students? The anions are bigger in size compared to the parent atom. Okay, now this atom possesses 288 electrons in the atom. Okay, now this is chlorine ion or anion. So now we get sodium cation and chlorine as anion. We get sodium as here cation and chlorine as anion. So it fulfill all the condition, that is it having low ionization potential, so it easily formed cation. It is having high electroaffinity, so it formed anion. Now the difference between them, that is the electronegativity difference, is higher, so this easily forms a compound NaCl, which is known as sodium chloride. Okay, sodium chloride. So the sodium atom donates its electron to the chlorine atom. Okay, the sodium atoms donate electron to chlorine atom. Now the structure is this is the sodium cation, right? This cation positively charged because the sodium donated electron and the chlorine accepted 1 electron, isn't it? So this is the final structure after the transfer of electrons. Okay, this is sodium ion and this is chloride ion. Okay, containing 2 8 electrons, and here it contains 2 8 electrons. Okay students, so the sodium atom loses 1 electron to form sodium ion and the chlorine atom accepts 1 electron to form chloride ion. So here I have marked as positively charged because it donates electron and it accepts electron, so it is negatively charged. Okay, the transfer of one electron. Lastly, it contains 8 electrons in the outermost orbit, and here also it contains 8 electrons in the outermost orbit. So these atoms fulfill their outermost orbit by attaining inert gas configuration. Okay, by attaining the nearest inert gas configuration. So here it contains 10 electrons. Now here it contains 18 electrons.